Now we all heard that the CPU is the brain of our computer, and that tells us that CPU is one of the, if not the most important part in our computers. But how many of you know that how a CPU works? Now you can go to the Wikipedia page and read, but it will be long and confusing. Hi, this is Akash, and in this series I explain some of the complex topics in computer and explain it in a simple, easy, fun, entertaining way. So if that sounds good to you, don't forget to subscribe. And in this video we are going to talk about how a CPU works. Now here's a disclaimer. All the stuff that we are going to discuss in this video are a generalization form of the computer architecture, and if you are preparing for an exam, skip this video, read your book. But if you are just curious and if you want to know, well, then this video is for you. And with that being said, now let's start the video. Now if we are going to discuss how a CPU works, we have to add another component in the game, and that is RAM. This is where CPU gets most of its information to do its stuff. Now CPU also has a inbuilt memory into itself, and that is called cache. It is much smaller than RAM but much faster than RAM. Now RAM and CPU are both different components, and to transfer a data from RAM to CPU it takes time, and the time is very little, but that little time can add delay. And that is where cache comes in. Cache send all the information CPU needs immediately because it is right on the CPU. But I will be discussing RAM and cache in some separate videos, so let's get back on to the CPU. So when you execute an instruction with a CPU, it goes through 5 steps. First, fetch. Get the instruction from the memory and store it in the cache. Second, decode. Get the appropriate variable needed for the execution of the instruction. Execute. Compute the result of the instruction. Memory. For instruction that requires memory read and write operation to be done. Write back. Write the result of the instruction and back into the memory. And each step take 1 clock cycle. That means a CPI of 5, and the CPI here is a clock cycle per instruction. Now most of the modern day CPUs can execute billions of clock cycle each second. For an example, a CPU with 3.4 GHz of clock speed can execute 3.4 billion instructions every second, but a CPI of 5 is inefficient after all. And that is where pipelining comes in. Asynchronous operation to computing. That means each step can be executed in different clock cycle, making a CPI of 1. That means it is very efficient. Now efficiency of a CPU depends on bunch of other things like loop unrolling, VLIWs, computer scheduling, data hazard, memory hazard, structural hazard, but all of this is beyond the scope of this video. But hey Akash, you said it's going to be easy, but it isn't. I know it was a little confusing, but believe me, this is the easiest way that I can explain to this whole topic. And second thing, now you guys know how I feel when I attend those 2 hours lectures at my college. But don't close this video, because how about I tell you how a CPU works in a simple way when you play a game. I think that sounds awesome. So when you download a game, it is stored on your hard drive, and when you launch the game, all the game's assets goes to the RAM. But RAM is just a storage device, and loading up assets on RAM is not enough to play a game, and that is where CPU comes into play. CPU is responsible for processing instructions and processing input from the player. Things like handling the NPCs, environment, simulations are all done by CPU, and that is why some of the simulation heavy games like Civ 6 requires a beefier CPU. One of the more critical role of a CPU is to pass all the information to the GPU. Now all the things I said earlier, remember all those things, now forget everything. But What do I mean by that? Think like your CPU is a highway, and on that highway your game's assets and all the instructions are driving as fast as possible, and that highway connects to GPU's VRAM. And as we all know, GPU is responsible for rendering the whole world, and VRAM is GPU's memory or GPU's RAM, you can say that. But the VRAM cannot access the RAM directly. That means all the assets has to go through from CPU to GPU. And also another thing that CPU does when you play a game, and that is tell your GPU that what to do. Your GPU is very fast and very much capable when it comes to rendering, but when it comes to thinking and know what to do, well, it isn't that much. And that what CPU does, tells your CPU what to do, how to render a game, how to render a world and whatnot, and also send all the information from RAM to your GPU. And you want to know the best thing? All of the things I said earlier, all the things are happening in just a single core. And as we all know, most of the modern CPUs has more than 2 cores. And there's also parallel computing comes into play, but those are the topics for another day. For now, if you like the video, hit the like button. If you don't, leave it a dislike. That works for me. And if you want to know what the core means, well, check out this video right here, and also you can check out this video. And to subscribe, you can press this button right here, and also you can do it by here. And this is Akash, and I will see you guys in the next one. Peace.